Now that we have our LedBlinker class, which is correctly set up and initialized, what do we need to do? So we want to make an LED blink. So we already have the LED, we want to make it blink with a certain rate. But just before that, if we want to make the LED blink, basically we want to toggle the states of the LED. So if the LED state was high, we put it to low. If it was low, we put it to high, okay? So what I'm going to do first is to create a method called toggle, toggle LED here, that we are going to use just after that when we implement the time functionality. And I'm going to put this as private, and you will see that why later. So I'm going to create void toggle LED as a private method inside my LedBlinker, which means that I won't be able to call this outside of the class. So I can't do here LedBlinker.toggle LED, but I will be able to do toggle LED inside the class, so basically inside the CPP file. So let's implement this void toggle LED. I'm going to put it there, LedBlinker, like this. So the order here doesn't really matter, okay? You could add this function after this, it's not really a problem. And well, to toggle the LED, I need to know the state of the LED. I need to know if it was set to high or if it was set to low. Basically, if it was powered on or powered off. And then I need to change that. So now I need to think of this. Do I want to implement this functionality here in the LedBlinker or in the LED class? And actually, this is much more of a feature of the LED, okay, to be able to toggle itself. Okay, we already have the on and we already have the off. Why not have a void toggle method that is going to simply power on or off the LED depending on previous state. So then we can call directly led.toggle. We can call LED on, LED off, led.toggle. And so I'm creating this. So I have first a prototype that I will need to define in the led.cpp. And now in my LedBlinker.cpp, when I do toggle LED, I simply do led.toggle. And that's it. That's the power of abstraction. So now, of course, I need to, so I have my toggle function here. I need to implement it. So I'm going to implement it in the led.cpp. I'm going to implement it there. Void LED toggle. Okay, and to toggle the LED, well, first I need the state of the LED, which I haven't saved before, okay? So I'm going to add the state of the LED here. Private, I have the pin, and I'm going to do byte state. So whenever I modify the state, I'm going to modify also this attribute. So now that I have a new state attribute that I want to update, well, first, before I actually toggle the LED, I need to update the state when I modify the state, actually. So when I do LED on, well, I power on the LED. So what I can do is do state is equal to high. And then I can do digital write pin high, or just digital write pin and state. That's the same thing. And when I do LED off, I can do state is equal to low, and then here replace with state. And also I am going to add in the constructor here, I'm going to just initialize state to low by default. Okay, so we already have a value, okay, because if we don't do this, well, we don't have an initialized value for state. So it's better to initialize every attribute here if we can in the constructor. So state low by default, just like this, and then whenever we call on and we call off, we are going to update the state, okay? And then in the toggle function, well, what I want to do is simply, if the LED is powered on, I power it off, else I power it on. So what I can do is if state is equal to high, then I can do off, and then else I can do on. So if it's powered on, we power it off, else we power it on. And one thing I can improve here is, well, here we are kind of in a higher level context, okay, because we use off and we use on. So this is still lower level context, okay? State is equal to high. What does it mean, okay? What I can do, I'm going to add a new function. I'm going to put it public also. Bool is powered on. So basically a new function that is just going to tell if the LED is powered on. And I put it public because that can be useful when you have the LED object to just know if it is powered on or not. So I'm going to implement this here. Let's put it there. Before or after, it doesn't matter. And I'm going to return simply return state is equal to high. So in this function, we abstract this, okay, so we just check if the state is equal to high, and then we say that the LED is powered on or not. So what I can do here is if is powered on, then we power it off, else we power it on. Okay, as you can see here, the context is much better. It's just like we can read it with some text. Okay, so now the toggle, let's verify the code. The toggle functionality is implemented, and as you can see here, I have an error. State was not declared in the scope because what? Because I forgot to add LED : is powered on. I'm going to verify again. So that's a very common error, okay, that you are going to do several times and that I do also all the time. Great, so now we have that toggle here method that we can use on the LED directly, and that we also use from the LED blinker for the next functionality we are going to add. If you want to test, so you may want to test intermediate functionalities that you add. In that case, well, the toggle is public, so you have the LED here. What you could do, for example, is to do LED.toggle, and let's say delay 500. Okay, so you can test this code just on the LED to see if the toggle is working correctly. So you should see the LED blinking every 500 milliseconds with this. And so to conclude with this toggle functionality, you can see that while we haven't added the toggle when we created first the LED class, simply because we didn't need it at this time. And that's how you should write your program with object-oriented programming, okay? Create the very basic functionality you need, and whenever you need a new feature, then write that code for the feature, okay? Just write the code when you need it, okay? That's the best thing you can do, because you will have the functionality and the goal that you want to reach in mind, and that's going to allow you to write better code and just code that you need, and not a lot of garbage code that you are never going to use.